Hey everyone, welcome to the final milestone presentation for Wisper. So I have Atahan and team joining us. So over to you, Atahan.
Hello. We can first start with the proposal we applied, and here we explain the project background. And the problem we solve is actually the decentralized messaging can be accomplished through something, but also we need anonymity and verifiable conversations in some cases, which is one of the examples is, let's suppose we are talking to a customer service and I say, hey, my phone just I dropped my phone to the water, and they say, no worries, like you can keep using it. And after they say this, I use it, and my phone is completely broken now because of the suggestion they made. But these conversations are held in the servers of the company. That means in the court, they can change the conversation, delete some messages, or reorder the message to prove that they didn't say that, but actually they did. So in that case, they reordered the conversation, like they said, you must send your phone to repair, but they didn't. Or they can just delete messages right away. So in these kind of cases, we need verifiable conversations. In here, we solve this problem using Mina, Mina's underlying zero knowledge proof architecture. And our main goal in the project is to leverage the client-side approach of the Mina and fully remove the central services that has rights to change a conversation. So in here, we use end-to-end encryption as another chatting services. But even though they say that they use end-to-end encryption, for many cases they actually don't, and they can delete some messages still because they are stored in the central server. But this can be accomplished using a DA layer or a relayer server or direct WebSocket connections as the communication layer. And our main focus is not the communication service, but the verifiable chatting infrastructure. So in here, we create some proof of every message, and we sign the message also. So now we have data integrity, because if the data is changed, the proof is not going to be verified, and also authorization, because we sign the message before sending them to the other party, and they are sure that they received the message correctly and from me, not another middleman or something. Plus, we use proof recursion for two main things. One of them is to hold the proof size at a constant size, because as the chatting grows, if we don't do recursion, it will not scale. In this case, since we recurse the proofs, we always have one final proof to send to the other party. And when they verify that message, they also verify all the historical message proofs too. And the second of them is to prevent reordering. So even though I can't change or delete any message now, I shouldn't be able to reorder them too, because they can manipulate the conversation by reordering, and we also solve this problem using zero knowledge proofs. Uh, we use Mina and also use a relay service, but we can use a DA layer or another. I can show you. We can use like direct Bluetooth connection, Wi-Fi network, decentralized, not decentralized, but open source server that relays the message or DA layers. We use direct WebSocket connections through each client, and in a client, we have the private and public key. So sending the data includes message, the signature of the message that to prove that I sent the message and not a middleman. And we have the recursive proof to verify this message, also all the historical messages. And I sent my public key in order to other client to verify. And we send the Merkle proof of the proofs, Merkle root, because in the two clients we construct the Merkle tree. In that way, we can settle this Merkle tree to Mina and verify not only the chat but every message individually if you want. So at the end of the conversation, we want to terminate the chat. We settle the recursive proof and the Merkle tree of proofs to Mina, and now they are all public. And in the code, I can just say I said this and verify it, and everybody can verify it also. This is the explanation of the architecture that I went through of it. And the data flow is the sender generates a message and encrypts it using the recipient's public key. Now, only the recipient can decrypt the message using their private key. And this ensures the authenticity and non-reputation. And in the, yeah.
Sorry, quick question. So at what point is this encryption and decryption made? So if let's say we two are chatting using SockFi, on client side, I would encrypt the message using your public key and send it to you, and you would on your end decrypt this. So in flight, no one can intercept this message and decrypt this. Is that the right way to describe it?
Yeah, of course. It's exactly how we do it. So as we said, we encrypt the message fully on client side, and the data transmission is agnostic for the protocol. But in our application, as I said, we use WebSockets to communicate through client, and everything is performed at the client side. All the proof generation process and the end-to-end encryption, the asymmetric encryption, all of them are happening on the client side. And at the end of the conversation, we deploy our final proof to Mina. So our long-term vision is to create MVP that we can communicate through clients, and we can verify the message individually and the whole conversation. And in the future, this can be used as a protocol that can be integrated into several other applications. And we develop the underlying infrastructure to accomplish that. And this is basically our project, as I can say this. Maybe we can go on with the demo.
Yep.
Kutay. And also, it's a verifiable setting. Yeah, you know, we all know that. And if you want to make it just anonymously, you can also do it. this public key is the other client public key that you gonna chat with.
And how are they discovering each other?
I know the public key of the other clients, and I'm creating chat with this public key, and it's a creation of the link, and I just shared the link with the other client, and this is how we connect. Yeah.
Okay, so it creates like a temporary, like a temporary lobby, and
Yeah,
that's
definitely.
where
Yeah.
you both enter. Okay.
Now creating a proof, but I guess there's a problem. Sorry. Hello. Why?
Maybe because of the connection of internet. Kutay.
Yeah, I guess I'm checking right now. Wait a minute.
Maybe I can explain the encryption part
Sure.
during waiting to Kutay. The encryption part, we are using Diffie-Hellman. This is how each client creates a shared secret key on their computer. I have a key pair, and the other client is, for example, Atan. Atan have a key pair also, and I'm creating shared secret key with using my private key and also Atan's public key, and Atan's do the same thing. So so we just have same shared secret key. So this is how we encrypt the data before sending to other clients.
And maybe can you speak a little bit more about how are you using like a package to create this lobby, or how is the session maintained between two participants in the chat?
Actually, in first place, we are using some server to make it easy. But like Atan said in proposal, this is not we want to do it because server, it's a centralized server. Maybe as a infrastructure, maybe as a protocol, it can be on server because, for example, if Atan has a company which want to use Wisper there, they can settle it their server. So it's not a problem because one of the clients is Atan also, so it's not a problem. So we are using it on server.
All right. So right now it is a center, but then you could take that out and use DA layer or something else.
This is our aim actually.
Computation. All right, cool.
Another side of the project is these people, we can say, they create a kind of local blockchain. There's a ongoing conversation about the after apocalypse things, and let's say after apocalypse, there's no internet, no anything. They can just communicate through Bluetooth, and they can chat with it. This is like a very end side use case, but this like ensures that the communication layer can be chosen with the demand. So if I need to make sure that the data is live, I can use a DA layer. But if I'm using it internally in a company, we can just use a central server to relay the message, and this doesn't harm the data integrity or the authorization of the message, etc. It is just a liveness issue, and it is all customizable.
Right. So it is like it's pretty protocol independent on how you could use it to communicate, and like you said, even in like extreme scenarios, you could use like you could swap the protocol and still continue communicating.
Yeah.
Maybe Demo.
Maybe we can go through the code to show how we do both the encryption and our ZK program, how the proofs are generated, how they are recursed, etc. Maybe we can go through the code and give a brief explanation about the code.
Yeah, it can be work actually.
Berkay, if you have the codes, maybe you can go through it.
Yep, I can.
Also, I can share also.
Okay then. Okay then.
Mm, here is the- Can you see my screen?
Yeah,
Yep.
we can.
You'll see.
Yeah, here is the ZK program for the generating proof. Berkay, can you explain?
As I mentioned before, Haresh, the recursive part is command line
Mhm.
because of the issue that I
Mhm.
already talked about. So so maybe you can just run the demo if you can. Or chat test. Yeah, chat test. It works. Yes.
Do you want to walk through one of the test cases, and I think we can use that.
Mm-hmm. Could I just run the npm run test and chat.test.ts file? Yeah, I think this is because of the version Kutay that you use. Let me show them.
And also right now it's working. Generating a proof. And games here.
Yes.
I guess we have just a little bit problem, you know.
No,
Yeah.
no problem. I mean, if the demo is working, let's do the demo. And,
Yeah,
and
The demo is
The
working.
demo
Yeah.
is working right now. But as a Berkay said, the recursive proof is not working right now because of the issues. But right now it's generating a proof and sending to other person, and he see the actual message from the encrypted message.
Yeah, we can see the message, right? On the right of the page.
Yeah.
Maybe we can
In here,
see the ingredients.
in here, the last message. Here is the content. Here's the encrypted message,
Mhm.
and also here's the here is the proof.
Mhm.
We will implement this recursion part after we solve it the issue, and also we will be ready to test with the Mina community actually.
Mhm. Cool.
So let's build Mina then.
Right. Awesome. And I think, does your demo or your implementation also have a way to settle to L1?
Yes.
And is that something we can show now, or is it an issue?
The settlement part,
Yeah.
actually, it's not ready because of the recursion part is not ready.
Okay. All right.
So we are just waiting for them actually.
All right. Okay. I mean, so if anyone's viewing this as a bug, we're just preventing recursion, and it's on Node.js, and
Yeah.
we're working with the team to figure out. So hence, this demo is slightly delayed, but we will circle back to it once it's done.
Yeah, definitely.
Cool. I'm just thinking, what other technologies are you using? What would happen if someone wanted to like share attachments? Is that something which can be supported now or in the future?
We are
As we mentioned in the proposal, the attachments, picture, GIF, maybe stickers, etc. They can be included in the longer vision using maybe third-party storage layers like IPFS or RWave, or maybe sending each other NFTs. This is also achievable through the chat. And in our longer vision, we want to implement these kind of stuff too.
Gotcha. And I guess maybe another way to think about it is currently it's only peer to peer. So what would be the changes to make it like a group chat? If is that possible or?
We are thinking the group chat also and voice chatting,
Mhm.
maybe video chatting as well.
Mhm.
But it can be achievable, I guess. But I didn't actually know how to do it right now.
Okay.
But
Okay.
I know we will do it.
All right. Cool. Cool. Awesome. Sorry, the demo did not work. But thank you for your time and
Thank you for
sharing your
your
progress
courage.
with us. All right. Take care.
Take care.
Thank you.
Bye, guys.
Thank you. Bye.